So yesterday we finished talking about sequences and we kind of stopped right there. To remind you, sequences are basically a list of numbers, right? And they're separated by commas, and we saw that there may be patterns on, how to find the terms in the sequence and so on. Today we're going to move on to series. A series is the indicated sum of all the terms in a sequence. So you get your sequence, that's a list of numbers. Now if you replace the commas with plus signs and you take the sum of all those numbers, that becomes a series. Now, there is a word here that I kind of glossed over. I said the series is the indicated sum. That word is important. So the indicated sum means you could sum up all of the numbers in a sequence, or it could just be a partial, like, the first 100 numbers, okay? All right. So just like we had a finite sequence, we have a finite series, and this is the indicated sum of all the terms in a finite sequence. And an infinite series is the indicated sum of all the terms of an infinite sequence, right? And you might ask, okay, what's an infinite sequence if I'm just adding numbers? Well, an infinite sequence is you're just adding numbers that never end, right? Plus 1, plus 2, plus 3, plus 4, plus 5, plus, and as long as there are numbers, you still add them. And so we'll see how that works. So take a look here. Here we have a finite sequence and a finite series. So the finite sequence, it's just a list, 1, 3, 5, 7, 9. A finite series, you just add all of them, and then you sum it up, and it's like, the numerical value. An infinite sequence is, 1, 3, 5, 7, 9, comma, ... and that gives you the understanding that that list is never going to end. And then that's what the series looks like. Not always. That's the tricky part. Okay?
Well, you give like a dot and then like the second half of it.
Huh?
So you give like a dot and like the second half of it?
No, we don't normally do that. We always like to start. Well, this is what this lesson is about. Okay? That's what we're going to talk about. Okay. Well, you know what? Before that, though, well, let me open it up. So the question was, if I'm just, if this is an infinite series, the question was, so then would the sum always be infinity? And I said no. So how is that possible? How could I be right? Yeah.
Well, if it's in the finite one, then it ends at 9.
Right, but we're talking about the infinite one.
Oh.
But does it always? For all infinite series, would the answer always be infinity?
No, it could be negative. Yes.
Well, but could it be a finite number? Could it be like 3?
Yeah.
How?
I know
How?
If like you had something.
Okay, yeah.
Let's say you had like 0 divided by, and then that's where you plugged in your numbers. It doesn't matter. You could go on to infinity, but then you keep getting the number 0. If it's 0 divided by.
So if it's 0 divided by something, it's always 0.
Yeah, but then you could keep plugging in infinite many series. You'll still get a finite number of 0.
Or if it's like any number over in the series, then it could be H.
So we're talking about like fractions now.
Is that right?
Right? Are we talking about fractions? Okay. So let's stay tuned and see how this conversation ends. Okay? Let's stay tuned. Okay. So here's how we define some of the terminology here. The sum of the first n terms of a series is called the nth partial sum, and the symbol is S sub n. So for example, if I wanted to find the sum of the first 3 numbers, I would say the third partial sum, and I would say S3. Like that. Okay? To find the nth partial sum, first you need all the terms up to that. So if you want to find the third partial sum, first you need all 3 terms, and then surprise, surprise, you just find the sum of all of them. Okay? All right. So let's take a look at this one, and let's find the 5th partial sum of this, right? Here we have an explicit formula. So what we're going to do is we're going to generate 5 terms because that's what a fifth partial sum means. So the first term, n is 1. So we generate that by saying 1 squared minus 3, negative 2. All right, here, same thing. 2 squared minus 3, that's a 1. And similarly, we get 6, 4, and what's the last term? I'm sorry, no, not 4. N4 is 13. And what's the last one?
22.
22. So S sub 5 is the sum of all of those numbers. Okay? Are we okay? All right. Here's another one. So S sub 4, right, is A sub 1 plus A sub 2, A sub 3, A sub 4. So what's A sub 1? 3. And then we have 6 over 2 squared. That's 3 over 2. 3 over 4. 3 over 8. Does everybody know how I'm generating those numbers? Yeah, because, okay. So now S sub 4, when we add them all up, is 45 over 8, which is also 5.625. And before you ask which I prefer, you know, it depends. Do you have your calculator on this section? Do you not? How is it? How are the directions explicitly asking you to give it? Okay. Okay. So that's the partial sum, the fourth partial sum. Okay, my favorite thing of all. My favorite thing of all. Sigma notation.
I hate
Okay.
You like this? It's so confusing.
Okay. So, what are we doing here? We're finding the sum, right? Okay. So, so if S is for sum, right? This is the English letter S, right? This is the English letter S, and what's capital S and lowercase s, okay? Now, in the Greek alphabet, the letter that makes the same sound as S, the S sound, is capital sigma. That's the S sound. I know. And lowercase sigma is that, okay? So the Greek alphabet, it starts off similar to Hebrew. It's alpha, lowercase, right? Alpha, beta, and then there is gamma, and so on and so forth. And then eventually when you get to there's like theta is one of the letters, okay? What else have we learned? Delta is one of the letters. It goes here, so capital delta and lowercase delta. What else? Pi is one of the letters that makes the P sound. In chemistry, have you guys learned? E equals H nu?
Yeah.
Okay, so nu is one of them. You've learned lambda. That's the L sound. Sigma is the S sound. All right. What else have you learned, huh?
Oh, the P.
The density one is the delta.
I don't know. It's like a slanted P.
Yeah, it is.
This one? Oh, like this?
No,
Yeah.
it's like.
It's kind of like
But this, that, like a curly, that's a rho. That's the R sound. That's a rho.
Oh, what about the
What
notation
else?
for like angular momentum? Doesn't that have a Greek letter?
Omega.
Oh, yeah.
Yes.
there you
Omega. That's another one. That's the O sound. That's the O. Omega. The
go. Angular momentum.
right. Capital Omega is that one. Right. That's Omega. Capital Omega. What else? Huh? Right. Okay. So all
Yeah,
of
that's what I was
the
thinking.
all of the sorority houses, right? Alpha, Kappa, Phi, and all that stuff, you know. So this is a Phi.
That's an alphabet?
This is a psi. Okay, so what's a
the psi and pressure, right?
yes, the psi and pressure. Okay, so what's a scientist's favorite movie genre?
Greek.
Sci-fi.
Look, sci-fi.
Oh, I got it! Let's
Sci-fi.
What a guess. Wait, what?
A scientist's favorite movie genre is sci-fi. Sci-fi.
Oh.
That's so cool. Okay, back to sigma. So eventually we run out of English letters, right? Like X and Y are like the variables, and A, B, C are like constants or like sides of a triangle, and then T is time, and capital T is temperature, and so on and so forth. So eventually we run out of letters, and so we have to use the Greek letters, and there are a lot, like each of these are used for like certain quantities, right? Like for example, angular velocity is omega, delta, nu, lambda, right? Theta, all of these are used. So eventually, it's kind of weird, like having gone through two. Okay, so I can say the sum of A1 plus A2 plus A3, blah, blah, blah. Or instead of the sum of, I could just say sigma. And when I'm walking down the street and I see that symbol sigma, in my mind, I'm like, okay, add everything that comes after it. Sigma just means sum, okay? Add everything that comes after it. So, for any sequence, all right, if I write this, okay, so that's sigma of AN. Okay, so sigma means add. What am I adding? I'm adding AN. From what to what? From n equals 1 to n equals k. So if I expand that, that just means, okay, put in 1, A1, plus put in 2, A2, plus put in 3, A3, and keep doing that and add them all up until I get n equals k. Okay, so that's the sigma notation, and it's a much more concise and like efficient way of writing things. So let's take a look at this one, and it says to find each sum. So look at this one. It says add up all of these things from n equals 1 to n equals 4. So basically, I'm going to add up A1, A2, A3, A4. So what I do is, okay, so for the first one, I put 1 in here, and I get 1 squared minus 1. Plus, now I put 2 in there, and I get 2 squared minus 2. Plus, now I put 3 in there. Plus, I put 4 in there. Okay? So do you see that? You have to, these are called counters, n equals 1 to 4. That's like your counter. So first you put in the first number 1, you evaluate, and then the 2, and then the 3, and then you stop when you hit that number on top. Okay? Yeah? So now it's just, left up to us to evaluate this. It's 0 plus 2 plus 6 plus 12, 20. Okay? So that's what that meant. Yes?
When, if you wanted to set it all equal to the answer, you do like the sigma for n equals 1 equals 20.
Yeah. So basically, in short, it would be the sum. Okay, so it's like this. The sum of n squared minus n from n equals 1 to 4 equals 20. That's what you meant?
Yeah.
Okay. So that's a partial sum. That's definitely a partial sum. We're adding up 4 little terms. Now look at the next one. This is what we were talking about before. I want the sum of this business 3 times 1 over 10 to the n from n equals 1 to infinity. So how many terms are there in this series? An infinite. Does it ever end? You just keep adding and adding and adding and adding and adding and adding and adding. So let's see how big this number will get. Oh my God, like if we add an infinite number of numbers. Okay, so if you know, don't ruin it. Okay, so the first one is, okay, so when n equals 1, can I write, okay, so when n equals 1, it's 3 times 1 over 10 to the 1, right? But can I write that as 3 over 10? Okay, plus when n equals 2, how much is it? 3 over 100. When n equals 3? 3 over 1,000, because it's 10 cubed. And then 3 over 10,000. Okay, let's just say plus dot, 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 because we can't possibly write every single one. You know what? That's not helping me that much. What are these in decimals? What's 3 over 10? 0.3. What's 3 over 100? 0.03. And 3 over 1,000? 0.003. And then 0.0003 plus dot, dot, dot. Now we have 2, yes.
It's 3 threes a line.
Oh, okay, it's okay. It's okay. Listen. Leibniz and Newton, they both invented calculus simultaneously but independently without knowing about one another. So it's okay. We everybody gets credit. Okay, so this is going to be, when you add them all up, 0.3333 blah, blah, blah with a bar. Now, don't you dare at this point in your life ever officially give an answer with that bar. Oh, that's like a math teacher's nightmare. Okay? So, how else can we write it though? 1/3. Okay? So, this is really 1/3. Okay. Because that's good in middle school, and then in real life, it's never good. That's only like, it's in middle school, that's a way for us to sort of like express a repeating decimal. But really what it is, it's an irrational, it's a fraction, right? So 1/3 and so on. Yes?
What happens if it doesn't work out that way when you're asking anyone you go to infinity? Is it possible? If it doesn't come out that fraction?
So, a lot of times it will. And we say when it comes out to like a cute little number like that, like we learned up here, we say it does what? It converges. So there are lots of series like this that converge to a number, or there might be a series that'll really like add up to infinity. So like for example, this one here, this infinite series here, you know, everybody's first instinct is right. That specific one the sum of that is infinitely large, okay? So it'll either be infinity or it'll converge to something. In this class, I'll stay away from the infinities most of the time. Yeah, okay? All right? Okay, so take a look at this one, and it says to write this in sigma notation. Now, and it says the lower bound is given. So to put this in sigma notation, basically what we're going to do is we're going to write sigma, and then we're going to put some formula there. Okay. And the lower bound is given. So n equals 1 is given. Okay, so it starts at n equals 1. So now look, if this is n equals 1, and this is n equals 2, 3, 4, 5, 6, 7, 8, right? Huh? Yes, but before I get there, I'm just counting how many terms there are, and it starts at 1 and ends at 8, so there goes n equals 1 to 8. Now, what you want to do is, let me write it here. So what you want to do is,
How do you know whether or not it's a sub n minus 3 or just n minus 3?
Okay, so here's what you want to do. First of all, you want to come up with a relationship that matches this number n to the term. So how does n match with that? So a lot of people are saying whatever n is minus 3 gives you that. Does that work for all of them? Yeah. So it looks like n minus 3 is it. Okay. So that's n minus 3. And now, whatever this is, that counter, right, that'll be the same variable as in there.
How come it's not for the thing at the very top?
It is. Those are the, so a sub n, right, that's the formula. So the formula for a sub n in this case is n minus 3. Okay, so that's saying whatever the formula is, and then it generates the terms. So that's how we do that one. Okay, so this formula relates each term with the value of n. Okay?
Is that the homework that we did yesterday?
Right. And now for tomorrow, you have to complete the whole homework. So this, hang on. I want everybody to do it like as a continuation. So this homework set will be one homework set altogether, right? So all of this will be due Thursday. Okay? Now, let's move on to section 2. So in this one, we talked about, yeah. All right, so we talked about sequences and series in general. But now there are two types of, like two classes of sequences. We're going to talk about one of them today. It's an arithmetic sequence and series, all right? An arithmetic sequence and series is one where the difference between successive terms is a constant. So for example, you create an arithmetic sequence when, let's say you start with a number, like, give me a number. 12. And then to this one, you're going to keep adding the same number. So let's say 2, right? So you do plus 2 and you get 14, plus 2 and you get 16, 18, 20, and so on. So now, the difference between each successive term is 2. The difference between here is 2. That's an arithmetic sequence. All right, so it's basically adding the same number over and over again. That 2 here, right, the difference between each term, we call it the common difference, and it's D. Okay, so take a look here. It says to determine the common difference, right? So what you do is you say D equals, and you want to do A sub 2 minus A sub 1. Order matters here. Okay, so D is negative 36 minus negative 53, 17. Okay, so the next the next 4 terms are what? So it's negative 19 plus 17, which is equal to 2. I'm sorry, negative 2. So then I have negative 2 and how much? 15, 32, and 49. Okay? All right, now, suppose I told you that there was this other sequence, and suppose I said A1 equals 5, and D is equal to 2. 2 is my favorite value for D. All right, so let's see. A1 is how much? 5, right? And then how do you get A2? 5 plus 2. And then how do you get A3? 5 plus what? How many 2's? 5 plus 2 times 2, right? Because it's 5 plus 2 plus 2. And then how do you get A4? 5 times how many 2's? 3. So 3 times 2. And then A5, 5 plus how much? 4 times 2, right? And so on and so forth. Okay? So if I wanted to now go all the way here, you know, A sub 6, 7, 8, 9, 57, 79, blah, 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 and then all the way here there is an A sub n. How would I be able to find that? Can I come up with a formula? Is there a pattern between all of these? First of all, they all have a what? They all have a 5 plus. And then 5 plus what? What else is in common? 2 something times 2. And what is that something? How does it relate to what term you're on? That's D, yeah, that's D. And then how about this one? Is it N? N minus 1. N minus 1. Okay? So, if I wanted to then come up with a formula, what would I say for AN? What's 5? Was that A1? Right? That was A1 all the way over there. So it's A1 plus N minus 1 times D. Okay? How are we able to do this? Because this is an arithmetic sequence and you're just adding the same number over and over and over and over again. Okay? So that's the formula. AN is equal to A1 plus N minus 1 times D. Okay? And look at this one here. They gave it to you, but you guys just came up with it all on your own, right? And so there is no forgetting, and you don't need to memorize it. You just know that, okay, each term is the first number plus N minus 1 times D's, because that's how many D you've added, okay? Now, what would happen if we labeled this A0? And then this was A1, A2, A3, A4. How would the formula be modified? Plus N times D, right? Then it would be AN equals A0 plus ND. We're going to use that later. Okay? All right? Yeah. Okay. So this one here, it says to find an explicit formula and then a recursive formula. So let's find an explicit formula for this one. Basically, AN is blah, blah, blah. So my formula for this is AN equals A1 plus N minus 1 D. And now I want to modify that for the sequence that we have. For the sequence that we have. Okay, so A1 is 14. How much is D here? Negative 11. Okay, let's put all that in. AN is equal to 14 plus N minus 1 times negative 11. I'm going to distribute. So that's 14 minus 11N plus 11. So A sub N is 25 minus 11N. That's the explicit formula. So now, right? So when you hear explicit formula, that's what you want up there. So that, okay, so now I could just use that and I could find like the 205th term, okay, without anything else. Okay, now I need a recursive formula. How do I find that one? What is a recursive formula? For those of you that were here yesterday, yeah.
You take the term up before it. You add the term before it and that term to get the next.
Right. So recursive formula is if you have one term, how do you get the next one? Okay. So for this one, this is what it needs to look like. You have to say what is A1. Okay. And then each term, right? How do you get each term? You get the term that came right before it, and what do you add to that? D. Right? Yeah, or D. So this is the general form. Okay? All right. So what's A1 here? 14. And then AN is A n minus 1 minus 11. That's the recursive. Okay? Yeah, you need to give both of those because you need to have a starting point. Okay? All right. Here, we need to find the 41st term. So I'm going to let you guys do this on your own. Basically, what you need is a sub 47. So what you're going to do is you're going to use the formula here in the blue up there. Whoops. And then you're going to find a sub 47. So figure out what you need. You need an n, you need an a1, blah, blah, blah. So go ahead and do it.
41, not 47.
Oh, I'm so sorry. Oh, sorry. It's the 40. Oh, sorry. Okay. Well, we'll do both. We'll do both. So D is, how much is D? -7. And N is 41. Okay, because there are 41 terms. So, and A1 is 11. So A41 is 11 plus 41 minus 1 times -7. And that's -269. But, okay, so A sub 47 is 11 plus 47 minus 1 times -7. How much is that? Okay. Questions? Because it's always, because the formula is always A1 plus N minus 1 times D. Right? Remember how we started here? You have your starting point, and then to that, you add each of the twos. Yeah. Okay. Okay. All right. So take a look at this one. You have a sequence, and you want to find the first term of the sequence. Okay. A44 is 229, and D is 8. Right. It's the same exact formula. So it's always this one. AN is A1 plus N minus 1 times D. Okay. So AN is how much? So AN is always the last term. The last term here is 229 equals A1 plus, how much is N? 44. Times D is 8. So finally, A1 is -115. Okay?